Iron is an essential trace mineral. Now, let us discuss the three main functions of iron in the body. The three primary functions of mineral iron in the body are the following. First, iron is essential for oxygen delivery to body cells. Second, iron is also a part of several proteins involved in the electron transport chain in the body, drug metabolism, and the immune system. Third, iron is also part of the enzyme catalase. Iron in the body is essential for oxygen delivery to body cells. Iron is a component of two oxygen-carrying proteins in the body, hemoglobin and myoglobin. Most of the iron in the body is part of hemoglobin. Hemoglobin in red blood cells transports oxygen to body cells and carries carbon dioxide away from cells for elimination by the lungs. Hemeiron also exists in myoglobin. Myoglobin is the principal constituent of muscles. Myoglobin is a muscle protein providing oxygen to muscles for muscle contraction. Iron is also a part of several proteins involved in the electron transport chain in the body, drug metabolism, and the immune system. Iron is also part of the enzyme catalase. Catalase is the enzyme in human cells functioning as an oxidative catalyst, decomposing hydrogen peroxide into oxygen and water before the peroxide can damage the cells. In other words, catalases protect human cells from the oxidative damage caused by hydrogen peroxides. Hydrogen peroxide is a byproduct of the body's metabolism. Hydrogen peroxides are free radicals. Free radicals are very reactive species and can move around very speedy in cells. Free radicals can attack and damage cell components through oxidation very rapidly. Oxygen is essential for life, but oxygen can also be poisonous. Excessive oxygen in the body can induce the formation of free radicals, peroxides and other reactive oxygen species, ROS. These reactive oxygen species are highly reactive chemicals and can damage cells through oxidation. Many trace elements interact with oxygen, some by assuring oxygen is delivered to cells and some by preventing oxidative damage. But unfortunately, minerals can also catalyze the formation of dangerous free radicals. To prevent the formation of free radicals, the body stores, transports, and uses these minerals in the forms of the protein complex. Therefore, these minerals cannot cause the formation of free radicals. For example, iron is transported in the body by binding the protein transferrin, and iron is stored in mucosal cells by forming a ferritin protein-iron complex. Ferritin is a universal intracellular protein that stores and releases iron in a controlled fashion. Ferritin is the primary intracellular iron storage protein keeping iron in a soluble and non-toxic form. In addition, ferritin acts as a buffer against iron deficiency and iron overload. Transferrins are iron transportation proteins produced in the liver. Each transferrin can bind two ferric iron ions tightly reversibly, mediating the iron transportation through blood plasma. In addition, various enzymes that contain trace minerals can destroy reactive oxygen molecules and protect cells from oxidative damage. Iron, copper, zinc, manganese, and selenium all serve as components of antioxidant enzymes. How much iron do we need? Now let us discuss the amount of recommended iron intake needed by our bodies daily. The recommended dietary allowance, RDA, of iron is based on the amount needed to maintain normal function but is only referred to as a minimal iron store in the human body. For males aged 14 to 18, the RDA is 11 mg daily. The RDA is set at 8 mg per day for adult men aged 19 and older and postmenopausal women. For females aged 9 through 18, the RDA is 15 mg daily. The RDA for menstruating women aged from 19 to 50 years old is increased to 18 mg per day to compensate for the iron lost in menstruation. During pregnancy at any age, the RDA increases to 27 mg daily. During breastfeeding, the RDA is 9 to 10 mg daily, and this lower RDA for iron than for non-pregnant women during breastfeeding assumes that menstruation has not resumed. Sutasty made this video. Thank you for watching, and see you next time.